Okay, thank you for the introduction, Thomas. So Living PDF is a company I recently founded together with two other partners. My background, as some of you may be aware, is in research. So I've been working on PDF tables for quite a while. I'll explain some methods for getting data out of tables and analyzing tables as well as PDF files in general today. As I'm sure many of you are aware, when a PDF is processed, typically we have a pipeline which looks something like this. We first try and understand the layout, at least of a page in the document. Then, if we're looking for tables, we move to table location. Then we move to actually understanding the structure, the rows and columns of a table. And finally, with this information that we've extracted, or rather recognize, we then actually try and find the respective rows and columns to extract the data. And this is a traditional approach of what's typically termed in the literature as document understanding. So the structure of today's talk, I'll go through document understanding in more detail. There's a lot of literature and a lot of most of the work on document understanding has been actually done on analyzing images of documents, because you can basically, you can turn anything into an image. So I'll first go through some techniques for, sort of OCR basics. Then I'll start looking at analyzing a PDF, at least a born digital PDF, or a PDF that has text embedded in it, which most business-oriented PDFs are, I believe, and working directly on the PDF operator structure. Can everyone hear me, by the way? Yeah. And I'll have a look at, I'll go through how sort of more basic, and not quite so basic rule-based systems work, and also summarize machine learning approaches. Then our machine learning approaches, as I'm sure many of you are aware, are quite difficult to actually figure out how they work and what actually goes on inside this black box. And this is why I'm proposing actually, and I think there's been a rejuvenation in explainable algorithms, as I've heard. I'm not the only one working on explainable algorithms, but I believe that, in today's AI world, where we really don't know what machines are doing, I believe they have an important part to play. And then I'll briefly look at using generative AI as well to extract data from tables and summarize with a comparison and conclusions. So, to begin with document understanding. The first step, and it's more for completeness that I'm including this image here, is basically to understand, before you do anything with a document, is to separate foreground from background. In most business documents, it's not usually a problem, but if the document isn't so clean or a historic document, then there might be difficult. It's not quite so easy to find out which pixels are foreground and which pixels are background. And there are various approaches in the literature, such as Otsu and Sauvala, which I won't go into detail today. But this is a step that, if we're working with clean PDFs, is actually relatively unproblematic. What I would like to say, though, is that most approaches throw away grayscale. So, we're saying a pixel is either black or white, and we are losing a little bit of information, which might be important, depending on how difficult the recognition task is. And then once we've separated the foreground from the background, again, assuming an image, then we usually try and find where the blocks are first the lines. We do a sort of, in the most basic form, a projection profile. We join pixels up that are black pixels that are close enough to each other, and find the lines of text. And if we do the same in the vertical direction, we find blocks of text. And these are that's how the early methods worked to perform layout analysis and segmentation, and such methods worked quite well given the limits in processing power back at the time. Now, the more simple rule-based methods that say we just join pixels together if they're less than, I don't know, 10 black pixels together if they're less than 10 pixels apart, means we ultimately end up with some issues in segmentation. Here we have letter forms that were maybe because the print wasn't dark enough, were separated, and then in the image, in the bottom image here, we have, I guess, a case of under-segmentation where the letters are joined together. And if we run OCR typically is actually is where machine learning is used, and old approaches, well, the first approaches would just be run on an individual character, and if we don't have the character boundaries correct, then we end up with the wrong result. And that's why in OCR there are improved methods that, for example, either use multiple hypotheses to segment a word, in this case, or window-based segmentation-free methods. Again, machine learning has improved quite a lot in the last couple of decade or so, and has some limited ability to actually recognize structures as well as just simply classifying a block into a certain character code. And machine learning basically is used to form the classification. Typically, what's used today quite often is some kind of neural network, convolutional neural network, and it's difficult to know actually how it works inside. It's trained on a very large data set, and the way OCR typically works is it then compares the recognized words with a dictionary, and chooses as a final result the best combination of segmentation, classification, and linguistic corrections or dictionary corrections, meaning that errors don't necessarily propagate by choosing the best optimization of all three aspects here. I mean, my personal idea is that, and this is research work that I wanted to be carrying out but haven't found funding for yet, is to improve the accuracy of OCR using an explainable typographical model. This might still lead to improvements, particularly where we don't have a dictionary to rely on. For example, digits, mixing up similar looking characters you might be able to better disambiguate between, for example, a lowercase letter L and a number 1 or a capital I, if you know what to expect given the font that has been chosen. But that's something that's planned for the future. So that was essentially the low-level document image analysis, and I'm going to talk about processing PDF directly, because quite often we actually have a clean PDF. I guess in the literature it's quite often termed born digital or natively digital PDF that's just been generated out of Word or maybe using a printer driver. And what we usually get is code, PDF instruction code. This is just taken from the PDF specification that positions usually chunks of words with their coordinates, quite often in order to facilitate kerning, as PDF fonts, when they're embedded in PDF, don't actually include any metric information or any kerning information or GPOS table. For every kerning operator, basically the block has to be broken, and then how does that work? This is basically there has to be an adjustment included between certain pairs of characters in order to make the spacing between the characters correct. In fact, I have to say many simple, particularly legacy systems that generate PDF, don't do so correctly. and you end up with some bad spacing problems because they don't look at kerning. I think quite possibly even my badge might be subject to that. But anyway, this is what the PDF kind of looks like inside. And when we analyze the PDF, we end up with typically these are the initial blocks that we can use. We could split them up into individual characters. It's not usually necessary. It just makes everything much, much slower. But as you can see, every time the word has been broken up, it's because there was a kerning operator in place. And from these blocks, we can join them together into words using rules, some more basic rules that say just depending on how close they are in proximity, join them together. We have the coordinates. We also extract images from a PDF in a similar way, although we have to take care of cropping. That's also applied to them in the PDF. Here's another example of such a PDF that's been subject to this analysis. In fact, one of the initial stages is to just join lines together in cases where there's justified text. Just looking at the line above or line below, it's possible to find out whether words that are further apart from each other also belong to the same line. And those are the more simpler rule-based methods, which we then can represent in a graph-based structure on several levels. So we have the initial fragments at the bottom, following that the lines, and then a whole paragraph of text, and the paragraphs that are neighboring can also be joined into sort of text blocks. So, does that solve the problem? Not quite. For simple documents, that may be enough, and processing in such a way is also very, very quick. Particularly if the text is written out to the PDF in its reading order, then we don't need to do a big search through all the text items or sort them in any order. It's enough just to join the neighbors together. So it is actually possible to process such PDFs very quickly. But quite often, the text might not be in the reading order. Typically, at least within a certain paragraph, within a given paragraph, it is in reading order, but that's not guaranteed, and that's something we need to cope with. As you see in this example, we actually have the whole the columns are kind of merged with each other, because they're written in one text instruction using these horizontal adjustments, which are actually intended or originally intended to be used for kerning adjustments. So in this case, we actually had to include a heuristic to break these up. There are other issues. For example, the character encoding may not be known, or it might be using a font which doesn't have the encoding kind of embedded in it, or is incorrect, like many older LaTeX output PDFs have been done. Also, there are cases, in fact, PDFbox library has explicit code to deal with this case where several characters are overprinted, but with very slight increments in positioning to simulate boldness, a sort of a fake bold. Particularly if the font is missing, that's something that has been done in the past. Because, again, if the print result is correct, who cares? Nobody did back then. And of course, we might just have a text as part of an image, which brings us back to the OCR problem. So we need to, it's nice to be able to deal with PDF using the clean operators that we have, but they don't solve everything, and we might need to resort back to the rasterization and even use OCR if necessary. So, starting with the characters and lines that we've extracted, we can actually start to recognize tables. Again, here I've got an example of a fairly simple table, but one that is unruled and based on the positioning. We can start, for example, in a simple way is to start looking at columns and try and find what looks like a column or a potential column, and then by merging the columns horizontally according to rules, it's possible to find a complete table. I mean, in this case, we started going vertically and then moved to the horizontal direction. And this is then what the final result looks like. Again, this is a table without spanning rows or columns or anything particularly difficult. And when we actually extract data from tables, we quite often even skip the step of actually trying to determine which columns are headers and which columns are data. If we're looking for particular text items, we then just look for the text that's there, and that helps. We don't have to do a full HTML conversion in that case. So what about the cases where that doesn't work as well? Again, if you were at my poster just now, you'd probably recognize this image. As you can see, with more complex layouts, particularly where there's less space, everything's packed closer together. You can't rely on simple rules to join text together. Otherwise, you end up here with over clustering. The reason is with simple approaches, there's not really, it's difficult to backtrack, errors propagate. Ultimately, we don't know at the stage where we're joining text, joining words to lines, actually that there's a whole vertical visually salient structure. And actually here, the words need to be broken up later on. Another example of a problem here is where we're joining vertically. This word gets broken up, again, because we don't have the full picture when we're just looking at the words at their lowest level. I'm going to jump now to using machine learning for structure detection. That was one approach. Well, there are several approaches for machine learning which have actually been quite good at dealing with such issues. I mean, they've generally concentrated on object recognition and other actually more difficult tasks. Many of the models that have been developed have been trained on sort of photographs of document images with uneven illumination, but they've been quite good at recognizing, at least detecting where tables are. However, they are somewhat limited in detecting the more fine structure on tables. And the other problem with using machine learning is that ultimately it's difficult to patch a system that uses machine learning. You can retrain it, or you can try maybe correcting misclassifications in a later step using rules again. And they also require a huge data set. And that's why my motivation was to go back to the rules and see if we can do something better using more flexible, fuzzy logic-based rules. And finally, also, there's no direct link to the PDF content stream. Once we've extracted something, we need to search within the original PDF for which operators actually created this. We're used to actually draw the text, particularly if we're interested in tagging the PDF later on. So this is why, this was, at least for me, the motivation to revisit explainable algorithms. Now, as I said, machine learning models, vision models are very kind of a lot more generic, but there are lots of hard problems, for example, natural scene detection, and compared to that, actually, I'll give you an example of the keynote this morning. It's difficult to say really, even in natural language, what makes a cat and what makes a dog. But I think we can more or less say what makes a table. We can begin to describe what rules make a table, at least visually, look like a table. That's the first motivation. The second motivation is that even though we actually, when we read, we don't look at individual characters. We generally, it's something that happens automatically. We look at whole words or larger chunks of visual data. And that is the way many machine learning algorithms work. But when we have more difficult recognition tasks, we do actually start looking at it again and analyzing the document, the image, and that's where it's good to have a model that really makes it possible to disambiguate fully using all the information that's available to us. And that's...
You're not so happy with machine learning?
Not overly. I mean, it has its uses, but I believe, I think machine learning can help us to find patterns that we cannot see ourselves. But here we're trying to recognize things that we can see, but machine learning sometimes makes us throw away information that's there. And this is why revisiting the idea of rule-based systems, explainable systems, the idea, I mean, what we've been working on is essentially a two-step approach with two components. Firstly, we have a model where the model is essentially the output of the system, with then a set of rules or a set of methods that are actually used to evaluate the output. So, for example, when we put the PDF's text with all its coordinates into the respective paragraphs, rows, and columns, we can actually use the model or the evaluation criteria, which are based on typical, I would say, typical graphical design rules and also text typesetting rules to say, is this really a paragraph? Is this really a table? Does this conform to the rules of the table and give us a numeric result, maybe between, let's say, 0 and 1, maybe it's 80%, 90%, depending on how far the rules have been broken. And there are examples of documents where rules have been broken. And I'd say this is moderately difficult to, it's not completely trivial to develop an evaluation model, but it's not the hardest part of this task. I'd say it's a lot more difficult to actually then start using rules to search through all plausible interpretations. Ultimately using the rules that would join two words into a line to search through the search space. And when we design the model, we basically have to, much like HTML or many other document models, determine what should the model actually be representing, and can this be common to a very wide variety of documents. There is always going to be certain structures in the text which the model won't be able to understand. This is something we need to be able to deal with. So this is just a graphical representation of the search space. As you can see, we are carrying out these steps, joining, clustering words into lines and lines into blocks. And we need to consider all plausible decisions. I mean, using a simple rule-based system, what we essentially have is we're following blindly a greedy algorithm, what seems to be the most, at the time, the best approach, the correct result, and we end up with a result which might not be it's a local maximum, it might not be the global maximum. But if we, at each step, consider other plausible decisions, then we can actually cover a much larger or a somewhat larger number of possibilities and hopefully find the global maximum in that case. And we can do this with branching. It's possible that also some backtracking might need to be carried out. Again, if we backtrack, we need to be careful that we don't repeat or go back to or revisit states that we've already revisited, that we've already visited once, because ultimately time is what we're trying to limit. So as I said, this searching through the gigantic search space isn't that easy, but we're making progress here. It's also, I guess, potentially plausible to even think about maybe using machine learning just to find a good search through the document space, through the interpretation space, but actually still have an explainable result. That's something that's maybe on the cards for later. So to summarize, basically, the simple rule-based with the more complex optimization approaches. Rule-based approaches propagate errors if the document is more complex. If the document is simple, and particularly in the case of PDF, text isn't too closely bunched, then quite often they work well enough. They're relatively easy to implement, and they're fast. And as I said, if the source is known, they may well be appropriate. The optimization, I've written here AI optimization. I realize nowadays the term is used differently. I mean here an optimization algorithm to find the optimal solution according to certain metrics can work very well. It's complex to implement. We do have a confidence measure, so if we don't find the result, we at least can be pretty sure that we haven't found the result. And depending on the search strategy, it may take longer to process. And just on a side topic, what we've been doing up to now has also ignored domain knowledge and even linguistic knowledge. So this is essentially how a machine sees a PDF and how we are seeing PDF with the algorithms that have been used up to now. And in this case, we can still see that we have a table, even if it might be not all that easy to recognize a table, particularly as we don't have ruling lines. So I'm going to move now to generative AI and just say a few words. I mean, there's been a lot of progress in the last few years, and LLMs have been very good at searching through huge amounts of data and generally finding solutions or returning something at least. Whether it makes sense or not is another issue, but I see them very much as a tool that can help us if we do get stuck, or if the explainable algorithm is given a document that doesn't really fit the model that it's been developed to work with. And there are various ways that we can use a generative AI to extract information for a document. Up to maybe a year ago, what we've been working on is basically we've still located the tables using the methods that we explained before, but then instead of trying to detect the columns and rows, we converted a table to text and then prompted the AI system to extract the data. So this might look like this, for example. And that can work quite well, assuming that the table has been cleanly extracted, but if there have been errors, they propagate. And more recently, with vision models being integrated in LLM systems, it's possible to just sidestep the whole process and, for example, just ask the GPT or a different LLM just to give it an image of the PDF, and then ask it to extract the information. And what it can even do is convert to HTML and give you a structured table, at least for certain tables. So how do we know that what we have is correct? We can still use the evaluation model that I explained a few slides ago to try and check whether the generative AI is actually giving us a good result or not. So what are the relative benefits and disadvantages? I'll start with the generative AI. I mean, I've been told generative AI has difficulty dealing with tables which aren't fully ruled. I need to test that out, I guess, a bit more thoroughly. It's easy to implement. There are no confidence measures, so you don't know if it's really giving you the right result. It's also quite costly. Again, if the optimization strategy is efficient enough, then it's probably going to be a lot less costly than generative AI. And ultimately, if we combine it with other approaches, then we can get the best of both worlds.
Multiple AIs or?
Well, essentially a model that can verify whether generative AI is giving you the result you want. I mean, my next slide actually, I guess, summarizes the two possibilities of combining them. I mean, the first, which might be a better actually method, is to use the explainable methods if they work. I mean, they're usually less processor intensive, and they return confidence measures. So, we know if we have a document that fits the model, then we know that we've been able to actually understand it correctly. And if it fails, we can then ask generative AI, which might give a different solution. But we don't know if it's correct. Or alternatively, we might use the work in the other direction to use the evaluation strategy that we've written to try and verify whether the generative AI result is correct or not. So I guess these are the directions we're actually working on essentially. At the moment, the first approach, kind of integrating generative AI into sort of PDF table recognition in order to try and deal with edge cases where the table that we have just doesn't fit the model. So yes, thank you very much for your attention. I guess one or two things that I wanted to say is that we're actually, currently the model that the algorithm that we've implemented works quite well on born digital documents, and we're planning on running it on the IGDAR 2013 dataset, which is a dataset consisting of not of images but of born digital documents, and generating some results pretty soon. So if you have any questions.
Yeah, thank you, Tom.
Yeah, thank you.
Yeah, there's time for questions here. Give you the phone. See? Oh, it's so the recording takes it.
Have you tried any of these approaches also with data cells that have a call span or row span other than one?
Yes, we have. Yeah.
And how have you found the results?
Well, firstly, if the table is fully ruled, then it's a no-brainer. If the table isn't fully ruled, then in general, they have worked quite well. Row spans are more difficult, and we're working on improving the rules because there are cases where it's not possible to really tell from the visual structure alone. We're trying to see how far we go just with the visual structure before we then start to use other information that's also present in the PDF or domain knowledge. But yes, that's something we do work with at the moment.
And based on the last approach, the hybrid approach, is it possible to assign the header IDs as well?
Header, you mean which cells are headers and which cells?
Yeah, and for the complete outline levels in a complex table.
It would be possible. We haven't actually worked on more than one outline level in a table, but we have been essentially converting tables to HTML. So we have also our heuristic-based approach for detecting where the header cells and data cells are. I skipped that in order to do the data extraction because you don't necessarily need that. Again, this is something that can't always be done perfectly. For example, if you have a table where all the headers are bold, then it's easy, but otherwise you have to sort of guess, okay, I have a lot of numbers here, but this is text, and it's on the left-hand side, then it's probably going to be the row header. Heuristics like that. So we do collect a list of attributes, which we then try and compare across the rows and columns. And obviously, if the rows and columns are on the border of the table, on like the first and like the top or the left, then they're a lot more likely to fit our model as header rows or columns. But that is a hard problem. And it is one that isn't completely solvable. We haven't really come across many tables with more than one level. Oh, I see what you mean. Like you have like a spanning. Yeah, a spanning one. Yeah. That's on the list. But yeah, this was something that was actually part of the model in the ICDAR 2013 competition. So there are a couple of tables in that data set. So I guess before we run our system on that data set, we need to make sure it at least attempts such tables. Thank you.
And how many rows currently you are trying to use in your system?
Rules, did you say?
Yeah. Do you know?
I don't know offhand. At the moment, this is very much hard-coded, and I think from a development perspective, we're thinking of maybe moving to a sort of more flexible approach. That's why I can...
Rough number?
Yeah, because the context is that maybe if you can have some set of the rules that can be applied, then certain type of the documents will, or the tables will be correct, yeah, and can be really focused on such.
Is this for efficiency? Once you've
yeah, exactly.
I've had this discussion before. I think the idea is once you've done once you've recognized one document, you know which rules can be applied, and then you can process the next documents more quickly. Thanks for the tip. And yes, performance, I have to mention, is still very much an issue, depending on the application. I mean,
typical phase because you are in the development. Okay. Okay. Any more questions? Okay. Thank you again, Tamir. And Gabriel.